Okay, good morning, all of you. So myself, Deobrata Kumar Das from Dumka Engineering College. Today we'll take the subject is control system. Okay, and the topic is Routh stability criteria, various examples. Am I audible?
Yes, sir.
Okay, so just wait, I'm starting. Okay, so let's start. So we have discussed in last classes that is the different types of examples of the Routh stability criteria. Okay, and also today we also discuss the another different types of problem in the Routh stability criteria also. So last class I am given you one problem. At first we have to discuss regarding the given questions, then we have to continue. So and the examples of Routh criteria. WITZ. So given the questions, determine the value of K such that the roots of the characteristics equation given below lie to the left of line, that is S equal to -1, and the given characteristic equation is S cube plus 10 squared plus 18s plus K, this is equals to 0. So this question we have given, that is the last classes also. Okay, so how it is solved? So first you have to read the question, determine the value of the K such that the roots of the characteristic equation given, this is the basically characteristic equation, and the value of the left of the line, that is S equal to, that is -1. So in that case we have to put the value of this S. So first put S equal to, that is S minus 1, and this s we have to differentiate here, that is s1, because this s we have to put it here value, that is s equal to -1. So we have to changes the name is here, that is s1. So we have to put the value s equal to s1 minus is 1. So the characteristic equation is coming in that case, that is s1 minus 1 cube whole cube plus 10 into s1 minus 1 its whole square plus 18 into s1 minus 1 plus k. This is equals to 0. Is it clear, all of you? Is it clear?
Yes, sir.
Okay. Simply we have to put the value of s equal to s1 minus 1 into the characteristics equation. So now you have to uh, calculate these equations. The equation is coming, that is s1 cube plus, I am written the final equation is coming. You have to solve line by line also. The final equation is coming h1 square plus h1 plus k minus 9. This is equal to 0. So these are the basically a complete characteristic equation. We have to put the value of, that is s equal to -1. Now you have to uh, prepare the Routh array table. You have to put the Routh array table from this equation. So highest order is, we know that s1 cube, then s2 cube, okay, then sorry, these are the basically square, not cube. Cube is, we have to retain here. This is also 1 minute. This is s1 square. This is also s1 to the power 1, and this is s1 to the power 0. So we have to put the value from this equation. So first value s1 to the power cube. What is the value is coming? Please tell everyone.
So 1,
First is 1, then
1,
is also 1, and any others?
no, sir.
No. Then next one s1 square.
So
Please tell
7,
7, and this is
so k minus 9,
k minus 9, and any others value is coming?
no, sir.
Thank you. So next one we have to understand the how it is calculated, that is s1 to the power 1. What is the value is coming? We know that this 7 into 1 minus 1 into k minus 9 divided by 7. Okay, so the value is 7 into 1 minus 7, that is 7 minus k minus 9. This is by 7, and this value position, that is also 0, because we know this is 7 here blank, that is 0 and also 0. So that means these are the basically 0 is coming. And what is the value of this position? s1 to the power 0. Easily you have to calculate it. This one multiplied by this one minus 7 into 0 divided by this one. So I am simplify this equation. The equation is coming, that is k minus 9. You have to easily solve. I am telling that this one multiplied by this one minus 7 into 0 total divided by this one. So you have to calculate it. These are cutting down. The finally equation answer is coming from this position, that is k minus 9. So now you have to value. What is the value? We have to calculate the value of k, and this k it is present in these equations. So we know that in this equation you have to solve, that is 7 minus k minus 9, this is equal to 0. So that means k equal to, that is 7 minus k minus 9, this is equals to 0. That means This is also K equals to, that is the 16, I think is coming. Okay. So that means one value is K equal to 16. Another it is K minus 9. This is equals to 0. That means K equals to 9. And both value, it is greater than the K is greater than the also K is value also. So the root, the value of K is greater than 16 and is greater than 9. The value root is present between these 9 to 16. So these are the basically ranges of the. So we have to written the K to have values between 9 and 16. So this is the answer. So this type of problem, it is also coming in your exams also. Is it clear, all of you?
Yes, sir.
Yes.
Yes, sir.
Okay. So next, another type of questions. Uh, number 2, examples number 2. The open loop transfer function of a unity feedback control system is given by, the equation is, that is Gs equals to K by S into S T1 plus 1, another one is T2 plus 1. Okay. So question is, and you have to given, that is applying Routh Hurwitz criteria, determine the value of, of K in terms of T1 and T2 for the system to be stable. Okay, so this type of question is also given in your exam. So question is, first you have to read the question. The open loop transfer function you have to given for a unity feedback control system, it is Gs equals to K divided by S into ST1 plus 1 and ST2 plus 1. So you have to apply the Routh Hurwitz criteria in this calculation also, and then you have to determine the value of K, which is K is coming in the terms of T1 and T2 for the system of the stable system. Okay. So first we have to calculate the characteristic situations. So characteristic equation is given characteristics equation is given by So this is S into ST1 plus 1 into ST2 plus 1 plus K. This is equals to 0. Now you have to calculate these equations. So that equation is coming here, T1, T2, SQ. You have to multiply this equation. Then the equation is coming this one, T1, T2, S to the power cube plus T1 plus T2 into S square plus S plus K. This is equals to 0. Okay, so these are the basically the finally we have to calculate the characteristic equation from the given OLT, that is open loop transfer function. Now you have to prepare the Routh array table from this equation, that is characteristic equation. So highest order is S3, that is SQ, SQ, then S2, then S1, and last S0. So please everyone tell me first S3. So which one? This is, please tell me.
So T1, T2.
T1, T2.
T1, T2. And next one, any other?
1.
1.
1. Very good. Next S2. What is the value of this one? This is
So T1 plus T2.
T1 plus T2. Very good. And next, this is K.
K.
Okay. So now we have to calculate, and any other position which is also blank, because here the lowest position is K also. So now we have to calculate for the position of S1. We have to learn that is this one into 1 minus this one into this one, that is K, total divided by this one. So the equation is coming, I have written here, this is T1 plus T2 into 1, that means 1, then minus K into T1 T2, okay, and this is divided by T1 plus T2, and this position is also, that is blank, that is 0. And what is the value of S0? I am written the S0 is this, that is S0. So this is also same thing, this one multiplied by this one minus this one into this one blank, that is 0, divided by this total. So we have to calculate that the value is only is present, that is also K. Okay, so these are the basically Routh array table we have represent from this characteristic equation. And here you can see the system is changes, that is a sign is not changes in the first column. So when the sign is not changes in the first column, that means the system is also stable. But when the any system is, that is a sign is changes, I am given the another example in the last classes also, you have to go through the last classes. So here are some sign is changes in that part. So now we have to calculate the value of the K. Okay, so I'm written here. So for the system, to be stable, first, that is K is greater than 0, this one. Okay, because always we have to learn the value is also greater than also all time, that is also 0. Okay, so this is the first relation. Number 2, this one, this is the equation, that is T1 plus T2 minus K into T1 T2. This is by T1 plus T2. And it is also greater than 0. So now we have to calculate this simplification. This is T1 plus T2 minus K T1 T2. Any questions, anyone? Yes, Deepak, any questions? Okay. So this is also this one T1 plus T2, this is multiplied by 0, that is also 0. So now we have to calculate this one. So we have to written this equation, that is K into T1 T2. This is also less than T1 plus T2. That means we have to written, that is K, it is less than equals to 1 by T1. This is T1 by 1 by T2. Okay, so this is the relation 2. Okay, so you have to easily calculate it is this value, that is T1. This is T1 by T1 T2. So T1 T1 cutting, that is T1 by T2. Another one, it is also 1 by T1. So these are the two relation we have to calculate it from here. That is equation 1 and equation 2. So we have to written in view of the relation. Listen, 1 and 2 following condition for stability is obtained. That is 0 less than K less than 1 by T1 plus 1 by. So this is the answer. Okay. So here you can see. So this is the basically open loop transfer function you have to give it. We have to apply the Routh criteria, and then you have to determine the value, that is the K, which is term T1 and T2. So these are the required calculations. Okay, is it clear, all of you? This example is very,
Yes, sir.
this example is very important. Okay, so please note down it. Okay, so we go to the next examples. Number 3. So number 3, it is a one another important for the control system of figure 1. I am drawing the figure in below with PID controller. We have read the PID controller in our earlier module, that is module 2. So this proportional integral derivative controller, find the condition for the system to be stable. That is TD equals to 0. So you have to given this type of also question. So you have to read the PID controller. This is the proportional integral derivative controller. So you have to calculate the value, that is when the system it is stable. So the figure, I'm draw the figure first. Input, we have to give in one summing point. So this is the hard case. Positive, negative. This is ES, error of the system. And this is the PID controller. The equation we know that KP, proportional controller, plus KDS, that is derivative controller. Then the integral controller, that is KI by S. Okay, so this is the PID controller. Then we have to one delay time circuit we have to attach for the summing point. This is positive, this is the negative, which is coming TD of the system. Then we have to apply the plant or process or plant. This is represent here KV by S into tau S plus 1. This is tau plus 1. Then the finally output we have to calculate it from here. And one unity feedback we have to attach. We know that this is the unity feedback loop we have to attach according to the output to the input of the summing point. Okay, so this figure we have to know this is the PID controller, and you have to find the condition of the system is stable when the TD is equals to 0. Okay, how it is solved? So first we have to calculate the expression of this given PID controller. So the expression is we know that is output of the system. We know that transfer function, it is the ratio between the output of the system to the input of the system, that is CS by RS. We know the equations. What is the expression of the PID controller in this given format? That is KV into KD square plus KPS. Those who have not understand, please go through the previous classes video. We have to one by one we have to explain, that is proportional controller, integral controller, and also derivative controller. Then tau is cube plus 1 plus KV KD square plus KV KP into S plus KV KI, and when the delay time, that is also 0. Okay, so these are the required expression we have to calculate it from the this given figure also. Okay, so now you have to calculate how it is. We have to put at the value in the Routh criteria also. So first we have to prepare the characteristic equation of the given system. So now the characteristics equation equation is from here, that is s cube plus 1 plus kv kd into s square plus kv kp into s plus. Anyone any question? Into. So we know that. So these are the basically characteristic equation we have to draw from the given system. This highest power is the s cube. Okay. So now we have to prepare the Routh table.
वहाँ पे ठंडा लग रहा है.
Yes, Mosam Mitra. Any questions or otherwise mute yourself. Okay. Up to this part, it is clear, all of you? Please respond me.
Yes.
Is it clear? Okay. Now we have to apply the Routh stability criteria, that means Routh-Hurwitz criteria. So first, you have to prepare the Routh additive. So apply Routh-Hurwitz criteria. So first you have to put the table, that is the highest power, that is s cube. Then also we know that s2, s square, s1, and then s0. So first, please tell me anyone what is the value of this first s cube? This is 1. Please tell me everyone. Then next one, this is kv into kp. That is 1, 3rd, 5th. These are the basically required position. And then second, that is 2nd, 4th, 6th, and so on. So this is 1. Then the second is kv, kp. Then S2, this one, 1 plus kv. Then kd. Next one, that is kp, so ki. Okay, so you have to easily calculate this position. We know that. So this is the equation is coming. I'm written here. That is 1 plus kv kd into kv kp minus of 1 dot this one. That means kp into ki, and total divided by, this is 1 plus kv into kd. And this value we have to represent here, b3. b3 b3 is equals to this equation. So we have to return the value is here, that is b3. And this position, it is also 0, you know that, because here you can see this is the blank position. So this one multiplied by 0 minus this one multiplied by 0, that means total system here, this value is 0. Next one is 0. How it is calculated? This is easily, this value is multiplied by this value minus this value multiplied by 0 divided by this one, dq. So you have to calculate it. The value is coming, that is kp, ki in this position also. Okay, is it clear, all of you?
Yes, sir.
Next part. So assuming all parameters and variables to be positive, the condition of stability is given as, this is the value is B3, that is equals to KV KP into 1 plus KV KD minus KP KI, and total this is greater than equals to the 0. Okay, so this corresponding the statement, it is made by earlier in the proportional integral and also PID controller, that is the proportional, integral and derivative controller part. So while improving this system, it is dynamic, okay, and it is reducing the steady state error. And this dynamic error and steady state error, how we have to calculate it from the first order and also second order, we have to broadly discuss in module 2. So please go through the module 2 lectures video from the YouTube sections. So you have to easily calculate the steady state error and also dynamic error also. So this second order system with a proportional controller, it is also stable in this format. Okay, this is clear all of you. So this type of question, it is also coming in your exams. Is it okay all of you? Okay, so everyone write your own name and roll number in the chat box also. And I have one class, please, it is continue. Okay. Next, another example. Another example you have to be solved, that is equation is given is to the power 4, 8 is cube plus 18 is square plus 16 is plus 5, this is equals to 0. Question is, consider the fourth order system of with the characteristic situation. So you have to given this characteristic equation. This is the fourth order system. You have to calculate the system, it is stable or not. So this is easily you have to calculate it. I am not written, not calculate from here. You have to solve by your home. This is home task. You have to apply the Routh criteria. You have to prepare the first Routh array table. Then you have to follow the first column. Any sign is changes or not. Then you have to system. You have to tell the system is stable or unstable. Okay. So after 1 minute, all of you please join the